Hello viewer and welcome to episode 4, which is decision making and operator. This is Gryff-User with this failure, and I'm going to discuss it through. So today lesson we get to go through decision making and all the operator. B1, this is quite hard as I go through all the operator. But we're also going to if then else statement. There's a lot to take in, so this may be a long failure. The lesson is quite tough. If you need a break midway in the failure, please pause the video and go for some fresh air. You may have to watch the failure twice and do the code there twice. Right, what are we waiting for? Let's get started. This is boot camp. It's meant not to be easy. The first thing we're going to go through is match function, and this is where we get all the wonderful method. And reminder, this method is class method, not instant method. That class method. So please, you need to import your maths class first, and then you need to put in the class first, which maths dot. And you can follow by the method. Oh, and by the way, pi is actually a class variable, so you need to put maths.pi. So we're going to go through cos, tan, and sine, and this is the argument you follow. This argument is actually weightings. If you want to use angle, you must use this. You must use maths to weightings, and you input your angle there, and you embedded this in here for cos. Same for tan, sine, so on. We're also going to do arcsine, arctan, arccos, log to the base 10, and special log to the power 7. Max, min, power, random. You name them. I will show that off in Java, so we'll do that much later on. Random. Java undergo a Bitwise random number generator. Now, that means the random number is generated by a given formula, and this is the formula in this case. You can read through that, because it's really not important, but if you're really interested, this is what you read. And so on. This is Bitwise random. Now, just to give you all the numbers, all the possible number, no, not really. It's sound enough, but it has some severe limitation. So it's nowhere near close as true random. You have a whole set of numbers, but they are not perfect. Not all bits are produced in equal randomness. So some number won't appear, and some number can appear more than once. It can tend to be a bit unfair, but for Java, it's forgiven. For gaming, it's forgiven. Not for the lotto number. So don't use for lotto. You can read this for more information. The one that is the best one is random.org, because this one uses atmosphere noise to calculate random number, and it's closer to true random. Alright, that's enough of that. The next one I'm going to probably cover is Unary Operator. Oh, simple math stuff. So when you do all the arithmetic, plus, minus, multiply the 5. What? 5 times 7. What? 5 times 10. You'll be asked all the wonderful stuff. Well, if you have to add, you can use plus. It's also used for string combination. If you want to multiply, you use this. 5 multiplied by 8. 5, that sign, 8. Now, please mind, if you combine, if you have put so many numbers and so many signs, if you come to that, you can use the but maths. It will work on the bracket, the innermost bracket first, work the outermost, then work to the outer brackets, bit by bit, then it followed by the integer, then the root, then division, multiplication, addition, and then subtraction. BODMAS. The next one is Unary Operator. This is where the increment and decrement matrix happens. If you want to use negative, use minus before number, negative value. So let's use a variable I. It can be any variable you want. Let's use it for I. I plus plus. That basically means I is declared first and get the value right on the spot, and then after that it increment by 1. That's post increment. So if I is 5 and you put I plus plus, you get the answer 5, and then it increment 1, which I is now 6. But if you use plus plus before the variable, say I is 5, I is incremented first, which you get 5. I is incremented first, so the answer would become 6. Then you get the I is actually declared and got obtained, and now you got 6. Now same apply for minus minus. Is allowed to decrement the value. Same apply for plus plus. Alright. Next part is quarter and Relational Operator. Now, if you want to compare, this is useful for comparing. Now, if you want to make sure it's equal to, use 2 equal sign, not 1. So many people, including me, made that mistake, and it really cost me. 2 equal signs. If you want a job, working in an environment, and someone watching you, and if you're caught with that mistake, or you'll be given out quite badly, and you might be punished, and they'll just push you, and they're going to say, "Wake up! 2 equal sign, not 1 equal sign." You get not equal to, greater than, less than, greater than, and equal to. This one, less than, equal to. Do not get confused. Suppose you compare it with 6. I get all this greater than 6. It'd be the number greater than 6, not equal to 6. Get that in your head. Not equal to 6. If you get greater than equal to the 6 equals 6, and everything greater than 6. Now, condition operator, and this is for inside the condition. Here we have the and the or. Now, how the and work is, if you get a condition and there is 2 of them, condition 1 and condition 2, and there's an and, that means both of them have to be true in order for it to be true. If one of them is false, then it is false. Now, suppose you use or. So, that means only one of them need to be true in order to be true. Only one. That's all you need. Just one or both of them to be true. Now, this next part is important, and please be careful, because I'm going to tell you, and I might discuss this in another episode, by the way. So, if you get condition 1, condition 2, and condition 3, and here so you put condition 1, and you use the AND operator, condition 2, and you use OR, condition 3. Now you're going to think like, I'm going to have condition 2. It could be either condition 2 or condition 3. That would be 1 bit. Either one of them can be true, and then you have the condition 1 that That must be true. You think that's gonna work? No. 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 That will not work. Trust me. That will not work. Because you're thinking OR, and you're gonna think OR gonna take precedent over AND. No. No, absolutely not. The result actually gonna work out is condition 1 and condition 2 must be true. Alternatively, or condition 3 has to be true. Okay? It's actually AND take precedent over OR. AND take precedent over OR. That is very important. AND take precedent over OR. That means AND go first, and then is followed by OR. Be careful of that. Now, there's a workaround. You can simply use bracket when that bracket comes first. Now, this one is another piece. It's tertiary. It's a shorthand for if then else statement. Now, of course, whether I say it just there, that's a bit confusing. So this is why I might have another failure. So I might have additional failure covering that, because it is confusing. So I might have another failure for that. This next one is tertiary. It's shorthand if then else statement. For now, we have if then else statement, and this is sample. This will go. This is a condition. In fact, only one condition, and you put a question mark, and this will be the true and the false. This is a true statement. So this is true. If this is true, then max will be equal to A. If this is false, then max is equal to B. It's equivalent to this. You're eventually going to be using that in professional practice. So if you're on a professional job like Java developer or junior or senior developer, and someone say no. Hey, listen. It'd be more efficient if you use this. You say, why are you using this? If this and this. If you use this, would be better to use this. Trust me, it's much faster, more efficient to do. It'd be nice and easy. Everyone understand that. So please, you might want to understand that before stepping in. Okay, if you want, let's give it out. Alright, next part is, and trust me, that last one is condition operator. So you probably won't understand that. So I might have another. If you do not understand, I have another video to cover that, and I try to clear off that. Alright, next is Bitwise and Bitship operator. Now, this sign is Unary Bitwise complement. How it works is, you type a number, and then it will convert to bits. It could be 8 bits, 16 bits, but 8 bits on default. Caution when using that. And then what I do is, all the bit is inverted. So 1 becomes 0, 0 becomes 1. And then it's calculated the number out of that. Now this one is signed left shift. Basically it's adding a 0. So if you have if you have 1, 0, which is 2, then you add 0 at the end would be 1, 0, 0, which is 4. If you get signed right shift, it's actually going to be 1. Because it was 10 and the 0 is shifted to the right, it'll be 1. Now left shift is actually the same as multiplied by 2. Right shift is almost the same as multiplied by 2 because all the decimal is dropped. Very useful for pistol. Now this would be for signed, the sign is maintained. This sign is ignored. Alright? Now, if you want all the bits, and if you are comparing the bits, like this is the gate. This is the gate operators. The first one is AND. That means if both of the bits is 1, then it is 1. Otherwise, it's 0. Now, excluding OR, XOR, if only one of the 2 bits is 1, then it is 1. Otherwise, it's 0. By including OR, if one or more of the 2 bits is 1, then it is 1. Otherwise, it's 0. Plain simple. Alright, next part is, I know this video is lasting long. Next part is if then else statement. This is how it works. First of all, you put in a condition. A condition, and then you follow by the true statement, else false statement. Now, you put in condition. Now, if the condition is true, it will follow by true statement. But if the condition is false, you put in the false statement instead. First of all, you put in condition, and you can use logical operator. You can use the AND or the OR. Remember the AND come first. AND operator come before OR. Say that over and over again. In a professional job environment, you do not want to get confused. Don't get confused, I'm telling you. And I'm going to keep saying it after a certain amount of time until we get that one right. Secondly, if this is true, if the condition is true, you can run the true statement. If this is false, it runs the false statement. Next is switch statement, and you can start with switch followed by favor inside the bracket. So you put switch, then bracket, then you can follow by this. Okay, and inside that you can put case. You put in case, and you follow by the value associated with the favor. So if the favor is I, you can put in value 10, 20, 35, so on. And value associated with favor. And repeat at the side. After each case, you put in the statement. Should that value is true and important to break. And then you use default. Now it may not be clear first, so that's why I'm going to show it on Java. Right, the next part is string format, and I'll probably have a spin-off episode for string format, because string format tend to be a bit confusing also. So here you go. Here how the string format work. So, and I do ask you viewers for the job again. You remember the string format. Off by that. I don't want you to see you working in the Java environment, looking at Google and looking at how to close the 2 decimal place, how to close 4 decimal place, and you look at the string format on Google. No, don't want to see you that, especially interview. So in the interview with Java, you better know string format. Okay? I don't care if it's hard. You better know string format. Okay? Understand? Good. Now, for string format, in order for string format to work, I tried this and it didn't work because the comparator is true. You're gonna need JDK 1.0 greater for format to work. You can go under project and then go on to property, and it should be on Java compile, I think. Or keep searching until you find that said JTK environment one time, and switch it to JTK 1.6 or greater. You can get that working. How about right? Now, the first argument for the string format. Now, by the way, you put in. It's actually string. String is a class. Dot format. That y is a class method. Dot format, and then you put in and the first argument is a string. It's a string, of course, and this method can read out certain special strings. The special string can be this: percentage followed by the index is 1. Dot 3f. The index. Oh boy, the index. 1, 2, 3. No, not 0. You want to be careful. It is not 0 index. That is frustrating. Because 1 as in first, 2 as in second. You wonder, first for the away index, and we have all the index. It starts 0. It starts 0. Index. First index is 0. Second index is 1. But why? And now certainly we have 1 as first index. So confusing, but this is one of you beware of the string format. The index start at 1, not 0. You get confused, but yeah, you're going to get the wrong index. Please don't let it happen. After the percentage will be the index. It's actually, I might put this easy. So if you want the index and index 0, you just say index plus 1. It's actually 1 greater. That would be the first thing. Sorry now. If you want the first argument, you just use 1. Second, if you want to get the second argument, 2, and so on. Then a dot. Then how many place the position you want to place? So 3f, 3 decimal place. Now to also trim it a decimal place, not really important. String dot trim. We're basically, now this instant method, you can trim out all the white space from the starting and the end. But I thought it might be useful. Decimal place, I don't find effective, but if you want to use decimal place, how this works is you put hash dot hash. Now, how many all the hash is determined, but if you only put in the hash, it determines how many digits you're allowing for before the decimal and before and after the decimal place. Alright, if you let's see how we're gonna check how long we've been through it. 23 minutes. It is expected. No, we're not done because I did say this is gonna long failure, so we'll continue on. Syntax error. Oh boy, I have a long laundry list for this. Oh boy. So, viewers, focus. Using case instead of switch. So suppose you use switch, but someone I type case choice and do this, and I put in the parenthesis, open and close and parenthesis, and then I use 5. No. That means you don't know switch. That is a big mistake. You might put in switch, and you put in your variable like choice, bracket, open parenthesis and closing parenthesis. You put in case. Secondly, you want syntax for if then else statement. No. Beware of that. Make sure you get the syntax right. Don't dare to get it wrong. Now switch fair to use before, fair to use the else statement. Well, not important, but it can be a larger error. Now, not using random number incorrectly. Yes, because you don't It's actually pretty much a larger error. I don't know why I put in syntax error, but it is a larger error. Now, another syntax error, and this is a big one. Using square root of a negative number. That in maths, that's basically impossible in real term. So in Java, that's gonna throw an error. You're gonna throw an error. So if you try to get that, you get an error. So you might want to use exception handler and use the lovely complex number. Next error, when using format failure to set to JTK 1.6 or later, that's actually a Java. That's actually an error. You're setting special string incorrectly. Now that's why I have another episode set up for that, so to help you avoid this annoying syntax error. Now, still don't work at 1090, but does help. Sorry, that doesn't make sense. Okay, this index, the index is not 0 index. It's start 1, not 0. So it's a silly confusion. So if you put in a percentage 0.3f and intend it, you're going to read the first argument. No, it's actually going to read the argument for the first argument, and that is a nutty on that one. No format. You get a number format error. It's actually start 1. Next one is larger error. Now when you're using switch, if you do not use break within switch, you're allowing this to go to next case, which it shouldn't, and that is a larger error. So please use break intentionally. Use an import statement. If there are many possible failures, switch is effective. If there are just 2 or 3, then everything else is effective. Pro use a Unary operator. If you confuse the sign of this and this, it's a big larger error. You do not want to get confused with that sign. So lo and behold, you got a number 6, and I'm going to keep inputting, and this is bad for while loop. So if you get a while loop, if you want the number 0 to 6, okay, but when it gets to number 6, so I want to include all the number 0 to 6 exclusively. That means no 0 to 6. Should be 1, 2, 3, 4, 5. So you use a while loop. And you actually start 1 simply. So you start 1 and then it just increments and so on. And then you make sure it is only less than 6. Only less than. Not more than, less than. And you will increment. So you don't want to get confused over that. Same. Make sure you get it right. Now, miscalculate a bitwise and bit shift operator. It is extremely likely. So, extremely likely. Be careful. If the else incorrect conditional operators, yeah, very likely to confusion. And you're confused over and or. So that's why I might have another video for that. Now, confusion or ignorance, you confuse this with this. It can happen. Tell you if you use that, you increment I before you use it. This you increment after you use it. If you do not know that, you're going to get this. I don't want to see you lacking knowledge of relational operator. Now, pure calculation knowledge of XOR gate or and bitwise operation. And is when both bit is 1, then it is 1, otherwise 0. or is if one or more bit is 1, then it is 1, or is only 1 bit or odd number bits. In case you have more than 2, then it is 1. There is a NOR gate, which both bit input is 1, then it is 1. Otherwise, it is 0. Where n is actually not all. Well, actually, I think that's incorrect because it's actually false. Yeah, sorry, but that one is not right. So I'm going to actually end the or go to larger or. If when both bit is 1, then it is 0. That should not have happened. I should not have that. Sorry. Okay. Now. Alright, I'm going to. Where is my larger tree? There you go. Now, larger tree when doing calculator function. Now, if you use 1090, you want to be careful because you're taking 1090 is going to be undefined figure and you're going to draw a center error. But this is a massive larger error. It's actually going to throw out this value. Yeah, you're going to throw out this value instead. It'll be a huge number and it's a larger error. If you use 10-0, you're going to draw extremely small value. And that is a bit a slip. And actually, although you're going to appear white in Java, no. When you're doing calculator, because 1090 is undefined and 10-0 is actually 0. And Java gives you a different figure. Java figure is not right. It's a larger error. So you might want to cover 1090, 10-0. Same thing for the cost. All that. The pi may be a bit inaccurate, causing the result to miss. It's not etc. in calculator. Now, advanced larger error, you can pretty much read through that. Pseudo random number generator and true random number generator. You can read about that. It's not really important, but if you want to read about it, but I tell you the efficiency. And the efficiency is greater for pseudo random number generator than the true number random generator. Now, that actually is easily influence the random number generator is actually pseudo random number generator. Yeah, that may be a hard one to understand. One thing you need to know is how to get computer generate true random number generator. But true random number generator, you need to be careful choosing the source. Like keep pressing, because you might have a lot of the same event while the program is waiting. And the program will know you have the same one at the same time. It will choose the effectiveness of randomness. So you want to be careful, but you don't have to worry about that. There is a workaround. You might get the program to work as a random.org using the internet, but it's pretty advanced. For a certain application, you need to use correct random generator and make it fair as possible and make efficiency. But the game is not really worried about it. The pseudo random number generator would do. You can use a background noise, but you have to be really careful. The fan can interrupt. Other larger gate and combating larger error. Now this is not. Now and, not or, not it's actually X, not or. It's pretty confusing. For the not, you simply use Bitwise shift operator. Now, not is not needed. If you want to get X, or you get the XOR first, and then you use this one, Bitwise shift operator. Shifting Y, when shifting Y, it won't give you a decimal place like that. might be covered for that. Alright, this is the pseudocode I'm going to do for my maths. Choose the PyDI team is this. Input angle of 0 to 90 degree excluded 3 times. Prove that PyDI's team is so cos A to power 2 plus this power 2 is equal to 1. And do the same thing. Prove that sin A divided by cos A and return tan A. Input the angle 90 degree for tan A, but this time prevent the undefined number with if statement. Here I'm going to use the scanner class to pass an integer. Now I use if then else statement. Shoot! Sorry, if then else. I hate one is accept 0 to 1 that accepts 0 to 2. Yeah, sorry, if then else statement 1 that accepts 0 to 2 5 high, another that control that. Except 2 to the power of 24 minus 1. And you see that whenever number you enter, you use a Unary Bitwise command to get the positive number as a result. But repeat 3 times. Now use scanner class to pass to integer. Now use logic gate calculation from 2 numbers. How long that lasts? Alright. Use the follow Unary Operator, often and Bitwise or Bitwise. Repeat 3 times. Use scanner to enter another integer. Shift the bit for resulting integer to the left 2 space and to the right 2 space. Shift the right integer to the left 3 space. Now, exercise 1. Create a program that utilizes logic gate. So on. Use XOR and OR to calculate. And 5 each logic gate, 99 and 214 each logic gate, 156 and 214 each logic gate, bitwise each number given, bitwise shift each number by 2 in each direction, avoid larger error. Write down answer before they appear. Write the code on Microsoft Word. This is a big one for us. So this is going to be a difficult exercise. And this will prepare you pretty well. Now you're also going to write this on the Microsoft Word. And you're going to do that. You're going to get tan sine cos at 33 degree, 30 degree, 132 degree, and I said degree. And you're going to close this down to 2 decimal place. If I'm going to see a long number and we do floating, if I'm going to see a floating at the end number, that I won't accept that. You got to close the 2 decimal place. Compute 17 to the power 2 plus 14 by 3, 20 by 5 plus the cube root of 2216 minus we made 23 divided by 4. Do it twice, one without bracket and another with bracket, and you see you get the same answer. Exercise 3. Create a Java that do without a power meter, 150 display on for 5 times. So you follow this. Now saving. I'm going to ask you to make change in putting most I have at this power precision into practice. Now I'm going to ask you to, out of all the exercise you did, you're going to make the error on purpose. Now this exercise I'm going to ask you to do a certain time limit, so try to do them pretty quick. And I'm going to tell you, eventually this is not important, but eventually I'm going to give you a time limit. And I'm going to ask you to do this right within time limit. If you cannot do it, you're not ready for the job. Don't even follow your CV until you get it, and instead try again. If you get it right in time limit, you can move on to the next episode. Now, do your exercise and get some fresher after that. If you're planning to do episode 4. Right, that's it. There your reference. And your reference 2. Alright, I'm going to stop the video right there and I'll be back soon.